For the derivative of this function, we have to recognize that we have a product here and a product here. So we'll be using the product rule twice to do this derivative. As a reminder, the product rule is the derivative of two different functions being multiplied. I'm going to call them u and v, since I'm already using f right here in the problem. This is equal to u prime times v plus u times v prime. So to do this derivative of f prime of x, first of all, here with the 2x sine of x, I recognize I've got a 2x and a sine of x. Those are the two functions. This is my u and v. And so I have u prime is 2 times v, sine of x, and then plus u, 2x, times v prime. The derivative of sine of x is cosine of x. Okay, now that's the derivative of this first part, but then for the second part, we again have two functions. We have x squared and e to the x. Call that u and v. So we have plus, and then the derivative of this u prime is 2x, that's the power rule, times v, e to the x, and then plus u, which is x squared, times v prime. Derivative of e to the x is still e to the x. So here's our derivative. We'd like to completely simplify in factored form. This as a whole does not really factor, but we could, if we'd like, take pieces that do have common factors. Like here, these first two terms, those have a common factor of 2. So we could pull the 2 out, and we're left with sine of x plus x cosine of x. And for these two terms, those both have an x and an e to the x in common. So we could pull that out as well, x e to the x. And then what are we left with? We're left with a 2, and then plus one of the x's and the e to the x are gone, so we're just left with a single x there. And that's about as much as we could do with this derivative. That's not much, but it is something.